Hey everyone, have you seen this shape before? And you think, what's it called? It's called an annulus. An annulus is, as you can see, it's a big circle and it has a hole in it, like a donut shape. That's called an annulus. A-N-N-U-L-U-S. An annulus has a special formula. The formula for it, to find its area, in this case the shaded region, we are basically using the formula pi, open bracket, capital R squared minus little r squared, close bracket. That's the formula. Let's see how we can apply it to find the area of the annulus. The first example, we can see that we would like to find the area shaded in red. We can tell that we have two radii. A radii is one radius. It's the single for radius. Radius is more than one, plural. We have two radii. We have the radii for the large circle, which is 8 centimeters, and we have the radii for the small circle, 5 centimeters. So now we're going to use this information to find the shaded area of the red shaded area in this figure. The formula A equals pi capital R squared minus little r squared. Because we have two radii, one of them is going to be the big one and one of them is going to be the small one. Which one do you think it's going to be? Well, of course, it's going to be pi. The capital R is going to be the large circle, the large radii, which is 8 squared. Take away the little radii, which is the 5 squared, which is the radius for the small circle. So what we're actually doing in this formula is we're working out the area of the large circle, take away the area of the small circle. That's exactly what this formula is doing. The large circle, take away the hole, the circular hole, which is the small circle with the radius of, or the radii of 5 centimeters. That's the formula, and that's what we're trying to do. What we do now is simply put the formula in our calculator. Remember, the brackets, always very important. Pi times, open bracket, 8 squared minus 5 squared, close the bracket. Very important to make sure you always copy the information down correctly and you always insert it in your calculator correctly. Now press equals. The area of the annulus, the area of the shaded part in red, is 122.52 square centimeters. So the shaded region, the red shaded region, in fact, is 122.52 square centimeters. That is the formula pi, open bracket, capital R squared, take away little r squared. The capital R is the radii for the large circle, take away the radii for the small circle, because in fact, like we said, it's a large circle, take away the hole, which is that small circle inside. That is the area of the annulus. Let's do two more examples. The next example, again we have an annulus, and we are asked to find the shaded region, which is here shaded in blue. We can see the radius for, or the radii for the large circle is 11 centimeters, and the small circle, it is 3 centimeters. So we would like to take away the small circle from the large circle to find the shaded region. Let's do that now. We have the formula A equals pi times capital R minus little r squared, all in brackets. That's the formula for the annulus. Now we substitute. Pi times the big R, we know the capital R is the large radius, which is 11 centimeters. Take away the small radius. We're basically working at the area of the large circle. Take away the hole, the circle that is in the middle there. Close bracket. Again, let's grab our calculator. Do it together. Do it with me. That way you can get used to it. Pi times, then we open the bracket, 11, and we notice here 11 squared minus 3 squared, close the bracket, equals 351.86 square centimeters to the nearest 2 decimal places. Very important that you copy down the information correctly, and always double check your work when you enter in the calculator. Same thing, that way you get the right answer, 351.86 square centimeters. That is the answer for the annulus, the shaded area in blue. Now we'll do one more example. The last example we need to pay extra attention for. Looking here, we can see again this is an annulus and the shaded area is in green. We need to find the area by using our formula. Our formula, once again, A equals pi, open bracket, capital R squared minus little r squared. Now we're going to use our formula. We need to substitute and find our large radius for the large circle, take away the little radius for the little circle. A equals pi. Now the large radius we can see is 9 centimeters. From the center all the way out to the large circle, it is 9 centimeters, so 9 squared. Take away the little radius. What do you think the little radius is going to be? It's going to be 6 centimeters. How? We know that the total large radii is 9, and we can see that the shaded area in green is marked with 3 centimeters as its thickness. That means the area or the radii inside the white circle is going to be left over. 9 take away 3, it's going to be 6. 9 take away 3, 9 is the long radii, take away the portion inside the green shaded area, which is 3 centimeters. 9 take away 3, the little radii is going to be 6 centimeters. Very important to pick that out. You look at the diagram carefully. Now that we know our large radii and our small radii, we can put it in the calculator and get it all correct. Pi times 9 squared, take away 6 squared, close our bracket, and 141.37 square centimeters to 2 decimal places. So the area shaded in green, the area of the annulus, is 141.37 square centimeters. Very important that you look at the diagram carefully, and remember, always memorize the formula. In this case here, the formula for an annulus, A equals pi, open bracket, capital R squared, take away little r squared, close the bracket. That is the area of the annulus.